let's at least talk about this guy here. It's talking about football on TV, and a Gallup poll conducted telephone interviews with a random sample of 1,000 adults aged 18 and older. Of these, 37% said that football is their favorite sport to watch on television. The margin of error for this estimate is 3.1 percentage points. Now, we haven't talked about margin of error, but it's a form of spread. So what this means is that this survey indicated that 37% think that football's the best sport to watch on TV, or that's their favorite one to watch on TV. But the estimate could be as high as 37 plus 3.1, so 40.1%, or as low as 37 minus 3.1, which would be what, 33.9%? So our estimate could be off by as much as 3%, basically. So between 34% and 40% of the true population, we think, would watch football on TV or prefer to watch football on TV. Now, the other thing I want to point out here, does anybody know what Gallup is? That's right. It's one of the major polling companies, and generally their polling strategies are pretty solid. I think all of the polling groups sort of missed the cue, or there was something going on with our last election because all of the polls indicated one thing and something else happened. So they're not infallible, but this tends to be a good. It adds some credibility to their statement there. So A, would you be surprised if a census, remember a census would be asking everybody 18 or older, would you be surprised if a census revealed that 50% of adults in the population would say their favorite sport to watch on TV is football? Explain your answer. Yes. The answer to this would be we should be very surprised, because we really wouldn't expect more than about 40.1% of the population to say that they like football. If this survey, which is probably fairly reasonable, is anywhere near correct. So the reason that this would be surprising is it's outside of our margin of error. That makes sense? It's way outside of our margin of error. Okay? So at the very most, we would expect about 40% to say that they like to watch football. Good? Everybody kind of understand margin of error? If it was within that amount, then it'd be like, yeah, no, that's not a surprise at all. But outside of it, yeah. And then B, explain how Gallup could decrease the margin of error. Yeah, exactly. Ask more people. Increase your sample size. That's exactly right. If you increase your sample size, you should decrease your spread, which is a margin of error, is a form of spread.
Could changing your location that you're pulling be different?
Well, if it's a truly random sample, we don't know what the population is. Can we make the assumption that the population is the American people?
Yes, I'm just saying, just maybe different. Is the 1,000 adults age 18 older, like was it?
That should be countrywide. So those 1,000 people should have been polled from the whole country. Yeah. If we can make that assumption that they're talking about U.S. adults, then right, everybody should have been part of that, or should have had an equal chance of being called. Does that make sense? Yeah. So I think we have to make the assumption that every U.S. adult had the chance to be in this 1,000. Okay? And 1,000 compared to the population of the United States doesn't seem all that much, but that's plenty big. But yeah, we would decrease our margin of error if we called more people. Okay. All right, let's look at 97. I definitely need everybody's attention on this one, because this one will hopefully sort of lock in that idea of statistically significant. So here we have a problem where a newspaper article is saying that most people are kissing the right way. That is, according to the study, the majority of couples prefer to tilt their heads to the right when kissing. In a study, a researcher observed a random sample of 124 kissing couples and found that 83 out of 124, or about 67%, of the couples tilted their head to the right. To determine if the data provide convincing evidence, the couples are more likely to tilt their head to the right. 100 simulated SRSs were selected. Okay, this is where it gets a little tricky. They're taking a computer and they're simulating this situation of people tilting their head to the left or the right. Now, the assumption that the researchers have to make here is that it doesn't make any difference. That half the couples would tilt their head to the right and the other half would tilt their head to the left. Okay? That it's 50-50. So back when I gave you the notes, I said assume results of an experiment to be equal. This is where you have to apply that. So they're taking a computer and they're saying, okay, I want you to basically flip a coin 124 times. Because it's either left or right, it's kind of like a coin flip, right? Flip a coin 124 times, and we're going to do that 100 times. And they plotted those sort of groups of coin flips, if you will, but left or right situations on this graph. And it says each dot on the graph shows the number of couples to tilt to the right is simulated in a simulated SRS of 124 couples, assuming that each couple has a 50% chance of tilting to the right. So if we're taking 124 people and we're saying that it's a 50-50 chance that they go one way or the other, then we would expect about 62 to be the middle, right? And 62 is right about here, and it looks like it is about in the middle. We've got roughly half in each side. Now, every time we sample that, whether it's a computer sampling it or us observing, are we going to get the same results every time for all 124 people, all 100 times that we look at 124 people? No, we're going to get slightly different results. And so this is representative of the slightly different results, given that we expect that 50% of the time they'll go one way and 50% of the time they'll go the other. Now, what we observed was 83, or what they say was observed was 83% of the time, or 83 out of 124 were tilting their head to the right. Is that in the top or the bottom 5% in this? Yeah, because the computer, at a model of doing a 50-50, the highest number of times that it did right first would be about 77. About 77 times out of 124, if the researcher's hypothesis of it's equal 50-50 turned up. So 83 is going to be even way out over here. So is that in the top 5%? Would that be in the top 5% of what was observed if the 50-50 is true? Yeah, so that's significant evidence that in fact people tend to tilt their head more to the right when kissing than to the left. Okay? Because our true value is way out over here. In fact, you would probably argue that it's in the top 1%, not in the top 5%. Does that make sense? So if it's here or here, it's statistically significant. If it's in the middle, it's just random chance. Okay? It's random chance that we had 69 times out of 124 or whatever. So, okay. Does that make sense for the statistically significant? Does that kind of help make those notes make a little bit more sense? I'm hoping. You got to be outside of the norm to be able to conclude that this is true.